Brad Ringer is a principal system engineer at AT&T. Today, he's going to share with you AT&T's journey implementing MuleSoft Runtime Fabric, as well as the benefits they've seen as a result. Brad, take it away.
Hi there, I'm going to be talking to you today about MuleSoft Runtime Fabric, the road to success. I'm Brad Ringer. I'm a principal solution architect at AT&T. Now my formal kind of job title versus what I do, I'm the lead integration architect for our business sales platform built on Salesforce. And I've been with AT&T for 20 years, hard to believe. And I am a MuleSoft certified developer, MuleSoft certified integration architect, and Salesforce certified admin as well. I grew up in Oregon, go Beavers, went to Oregon State, and I'm currently based out of Seattle. And as like all of us, due to COVID, I am working from home. And a fun fact about me, I have visited 21 countries. Our agenda will kind of go over today. I wanted to talk to you guys. This is going to be more story-based rather than technical, so I kind of wanted to go over our business Salesforce implementation, how we built our MVP solution, and then truly how we ended up with Runtime Fabric, all the options we went through. And then lastly, we'll have a few takeaways. So what is our business sales CRM platform? It's a platform that supports on Salesforce all of our business sales, really for B2B sales. We've moved our solution out of a legacy system called Siebel. You may know about that. A little bit more of a monolith, and we're using it for lead, opportunity, and sales funnel tracking. And with this implementation, we're really focusing on best practices. We've had a legacy system in the past that had 10, 15 years of projects and solutions built on that. So we're kind of looking at moving away from custom into really building an extensible, standard, best processes-based solution with really maintainable architecture. And at the key of that Salesforce implementation is really MuleSoft. You can think of MuleSoft as, it's our integration layer, of course, but it's really anything in or out of Salesforce we're using MuleSoft for, so that ingress and egress layer. Of course, there's some app exchange packages and things like that we're using from an integration perspective, but any APIs or data or anything else, batch processes, we're using MuleSoft for. One of the big questions everybody has with these SaaS platforms is, okay, we've got Salesforce, okay, we've got MuleSoft, and then we've got our company internal applications, whether that be microservices, API gateways, any legacy systems, Siebel, whatever, SAP. How do we access them over the network and cross that fine line that is that firewall? So what we're going to go through is kind of how we did that for our MVP solution, and then really how we ended up with the solution that we have now. And the first step was really our minimally viable product. We had 3 months to really go from ideation to implementation. And so we had to kind of do, I call it a skunkworks deployment, where we needed to get something out the door, and this was the easiest way to do it. So what we did was really leverage CloudHub. And as part of that, we set static IPs for all of our applications, and then created a reverse proxy to cross that firewall with those static IPs whitelisted to access those internal applications. The problem was, we can talk about really, is phase 2 the right way? How did we handle that? We knew that first MVP solution wasn't going to work well. So how could we make a solution that would really enable us to move forward? I mean, that first solution, everything required a static IP. I mean, you guys can understand, I mean, how do you handle dev, test, production, even unit testing? How do you handle that across multiple applications? So you can think, okay, we had to do a static IP for each of those, and then you have to go to a team that manages that reverse proxy for each of those static IPs. It just grew exponentially. So the problem was we knew that wasn't going to be a workable solution moving forward. So the next steps we went through was really working with our MuleSoft success team, Ashwin Krishnan, Gilles Ramone, and our MuleSoft account manager, David Byrne. And they really helped us kind of look at some options to really build a platform that we can move forward with. So that our success team was able to kind of guide us through a few solutions. So the first one we looked at was really CloudHub, right? I mean, that's what MuleSoft provides. That's what, I mean, it's the iPaaS solution with infrastructure built in, maintenance, all of the easy or difficult things that we have to do, right, to maintain an infrastructure. I come from really a production support background, so having to maintain servers, do the patching, all of that, I mean, CloudHub takes that away. So what we looked at first was really an IPsec VPN, meaning we would build a VPC in CloudHub, and then we would have an IPsec VPN access that. I mean, you have to do some setup in CloudHub as well. But the problem that we ran into with that was we needed to have a CIDR block of IPv4 IP addresses that we could route. And unfortunately, given restrictions, of course, on IPv4 addresses, that wasn't really an option. Another option was VPC peering. So we looked at really, if you've heard of VPC peering, it's really connecting two networks. So we didn't really like that solution because that really you have a MuleSoft account, you have an AT&T account. We didn't like really joining those together and not having control over what's going over that network. The other option was Direct Connect, which is really probably an option we're looking forward for the future. But from an application team perspective, there's multiple Salesforce implementations at AT&T as well as MuleSoft. So having a single Direct Connect connection tied for a single application team didn't make sense due to cost as well as infrastructure. So we're looking at that longer term, but that's definitely not something that we pursued at that time. So the other option we looked at was really on-prem, right? Everybody has at least one time done a Mule implementation on a bare metal server or a VM or whatever you have in place. So could we make that solution work on our VMs that we have inside the network, inside the company network? So yes, from an implementation perspective, no problem. We've got servers. We'd have to build a HTTP load balancer in front of it, but no problem. The problem again was, well, the firewall. How do we get across that hard connection that we have, or hard block that we have, to pass that connectivity? And really what we looked at was the other option was a reverse proxy to cross that. Well, we couldn't really, the problem was if we use the same solution that we did initially in the MVP with the IP whitelisting, we would have to say, okay, from every Salesforce IP address that we could possibly use, can we cross that same reverse proxy? And the amount of IPs and whitelisting that would need to be done just didn't make sense. So we ended up with Runtime Fabric. Kind of the title of this presentation, The Road to Success. So what is Runtime Fabric? I really look at it as a software appliance. So think of it as an appliance that you install in your kitchen or wherever, but kind of from a software perspective. So I've got whatever platform you have, AWS, your Google Cloud, Azure, or even on-prem, you basically take that appliance and install it on your own implementation, or that PaaS system behind the scenes. So that's kind of what we did. And RTF as a whole, it's Kubernetes-based, container service, and it really automates the deployment and orchestration from your control plane, any point control plane, so standard, just like you do with CloudHub. So why RTF, right? So it gives us that appliance, and then we actually use AWS. So it lets us kind of take the best of MuleSoft, and then the best of AWS with SQS and S3 and all of the standard functionality that AWS provides. And then on top of that, the connectivity inside, secure connectivity inside networks, such as Private Link, AWS Direct Connect, that we'll touch on here in a second. So the three-layer cake implementation, I call it. We've got the base layer, right, that everything is built on. That's AWS. Then we've got that appliance that MuleSoft provides us, software appliance, that plugs into that AWS implementation. Okay, that's our pure runtime fabric layer that's really depicted here in this first box. And the second piece of that is, okay, we've got our standalone AWS account, right, for our application. How do we connect that inside the network? And what we've done at AT&T is build out what we call a network zone or our bastion VPC. Really think of it as is this box over here in the middle that crosses the firewall. We build out a proxy there, you can think of it as, with that direct connect connection inside, crossing that firewall into the network. And we use AWS Private Link to go from our application RTF implementation using Private Link to that. So you have basically our account here. You have the AWS Bastion regional account that we have, and that crosses the firewall for us. So that's that three-layer cake that we've got talked about, right? So here's an overview of kind of from a networking perspective how that looks. We've got a bidirectional flow, so you can think of it as it's a little different. This is really right to left versus left to right, but from a internal network perspective, if we wanted to call a Salesforce API, we wanted to get opportunities or leads or whatever else, right, from Salesforce, you'd call using really a transparent layer from inside the network. You call a URL, FQDN, that then transverses this whole layer over private link to Salesforce and returns that data to you. And then the same thing in the reverse, right? From Salesforce, you call a network load balancer that goes to the Mule layer and then crosses over private link all the way in from direct connect to whatever application within the network you're trying to access. How hard was this, right? I mean, that's kind of the big question was, how did we do this? How difficult was it to set up? Given all of the excellent documentation that MuleSoft has provided and really the Terraform scripts, it took a little longer for our dev test, but I mean, once we've had all the steps down, I mean, it took us 15 minutes to build out an entire production environment. That included some manual steps to set up the load balancer as well as the private link connection, but truly it was standard AWS tooling, security groups, things like that, to set this up with a Terraform script that we ran from our desktop. So truly 15 minutes and easy as pie. There was nothing to it. So that has been one thing that has really progressed over the life cycle of the RTF product is the tooling and implementation and logging and all of those details and stability of the platform have improved greatly over the last year. The big question, does it work, right? I mean, great, we implemented this, but does it really work and meet our needs? So thankfully, yes. Yeah, we've implemented a solution that really meets those requirements to provide that connectivity in and out of the internal network to Salesforce, as well as to vice versa from Salesforce inside the network. So we have a reusable pattern that's being used across the enterprise. There's other teams within AT&T using the same pattern. And it's really extensible for our future needs. So you can think of it as we expand, we can add additional workers if we need to, kind of that horizontal scaling, or if we need to increase JVM heap or something like that, we can scale vertically and increase those within AWS, just increase the service sizes. We go from a large to an extra large or whatever we need to meet that vertical scaling need. And I have to say, the implementation and how well MuleSoft engineering has done on this product has been exemplary. I mean, we went from kind of a difficult implementation to start with to, I talked about 15 minutes and really it's stable. I mean, as I said, I come from a production support background, so having to bounce servers all the time and do nightly bounces to keep things up and things like that, you just don't have to do. It's been quite a stable platform. So kudos to Mule Engineering for that. And then one of the kind of things we're really excited about is Salesforce Private Connect. I don't know if you've heard about this, but it's really kind of Salesforce implementation of kind of the same pattern that we're doing with having a AWS account, which is Salesforce connecting over private link to another account. And what that basically will allow is a totally private connection. You can think of it as, rather than going over the internet and then going back to AWS and then going over that private link, you can truly have a private network connection all the way from Salesforce to our AT&T internal network. So of course our security teams are super excited about this because really there's no internet transversal at all. I mean, technically that's your transport layer, right? But everything is over that private connection that's been built. So a few takeaways from this. Hopefully I've given you kind of our decision-making process and how we went through a few of these patterns to access assets within our crossing that firewall. Discussed how RTF has provided an extensible appliance that we can use to leverage kind of AWS best practices and AWS patterns that's why AWS is around, right? I mean, they've got all of these great tools that we can use, SQS, S3, all of this great tooling in place that RTF and Mule can now leverage. So really, we're super excited that RTF and AWS have kind of given us the best of both worlds. We've got that cloud that we can manage ourselves and all of the tooling we can manage ourselves with really a MuleSoft appliance we just plug right in. So if you have any questions, we'll follow up in the live chat. I'll be available there for any more technical details or anything. Or if you wanted to, you can reach out to me on my LinkedIn as well. Just wanted to say thank you.